Earthquakes. What are earthquakes? The shaking or trembling of the earth/ground caused by the sudden release of energy, usually associated with faulting or breaking of rocks. Continuing adjustment of position results in aftershocks. What is the elastic rebound theory? Explains how energy is stored in rocks. Rocks bend until the strength of the rock is exceeded. Rupture occurs and the rocks quickly rebound to an undeformed shape. Energy is released in waves that radiate outward from the fault. Types of faults. Dip-slip fault. The focus and epicenter of an earthquake. The point within Earth where faulting begins is the focus, or hypocenter. The point directly above the focus on the surface is the epicenter. Seismographs record earthquake events. At convergent boundaries, focal depth increases along a dipping seismic zone called a Benioff zone. How seismographs work. Seismic motion. Where do earthquakes occur and how often? 80% of all earthquakes occur in the Circum-Pacific belt. Most of these result from convergent margin activity. 15% occur in the Mediterranean Asiatic belt. Remaining 5% occur in the interiors of plates and on spreading ridge centers. More than 150,000 quakes strong enough to be felt are recorded each year. The economics and societal impacts of EQs. Damage in Oakland, California, 1989. Building collapse. Fire. Tsunami. Ground failure. Earthquake damage. Landslide. Liquefaction. Tsunami. What are seismic waves? Response of material to the arrival of energy fronts released by rupture. Two types. Body waves. P and S. Surface waves. R and L. Body waves, P and S waves. P or primary waves. Fastest waves. Travel through solids, liquids, or gases. Compressional wave, material movement is in the same direction as wave movement. S or secondary waves. Slower than P waves. Travel through solids only. Shear waves move material perpendicular to wave movement. Surface waves, R and L waves. Travel just below or along the ground's surface. Slower than body waves, rolling and side-to-side movement. Especially damaging to buildings. Seismic waves paths through the Earth. How is an earthquake's epicenter located? Seismic wave behavior. P waves arrive first, then S waves, then L and R. Average speeds for all these waves is known. After an earthquake, the difference in arrival times at a seismograph station can be used to calculate the distance from the seismograph to the epicenter. How is an earthquake's epicenter located? Time-distance graph showing the average travel times for P and S waves. The farther away a seismograph is from the focus of an earthquake, the longer the interval between the arrivals of the P and S waves. How is an earthquake's epicenter located? 3 seismograph stations are needed to locate the epicenter of an earthquake. A circle where the radius equals the distance to the epicenter is drawn. The intersection of the circles locates the epicenter. Locating an earthquake. How are the size and strength of an earthquake measured? Intensity. Subjective measure of the kind of damage done and people's reactions to it. Isoseismal lines identify areas of equal intensity. Modified Mercalli intensity map. 1994 Northridge, California earthquake. Magnitude 6.7. How are the size and strength of an earthquake measured? Magnitude. Richter scale measures total amount of energy released by an earthquake, independent of intensity. Amplitude of the largest wave produced by an event is corrected for distance and assigned a value on an open-ended logarithmic scale. What are the destructive effects of earthquakes? Ground shaking. Amplitude, duration, and damage increases in poorly consolidated rocks. Can earthquakes be predicted? Earthquake precursors. Changes in elevation or tilting of land surface, fluctuations in groundwater levels, magnetic field, electrical resistance of the ground. Seismic dilatancy model. Seismic gaps. Can earthquakes be predicted? Earthquake prediction programs include laboratory and field studies of rocks before, during, and after earthquakes. Monitor activity along major faults. Produce risk assessments. Can earthquakes be controlled? Graph showing the relationship between the amount of waste injected into wells per month and the average number of Denver earthquakes per month. Some have suggested that pumping fluids into seismic gaps will cause small earthquakes while preventing large ones. Some notable earthquakes. Files of largest earthquakes. Earth-slate structure. Moho is the boundary of the crust and the mantle. Lohmann discontinuity is boundary between the inner and outer core. Layers defined by composition. Crust. Oceanic crust. Basaltic composition. Density 3 grams/cc. Younger, 180 mi younger than the continental crust. Continental crust. Mantle. Below crust to a depth of 2,900 kilometers. Composition of the uppermost mantle is the igneous rock peridotite. Changes at greater depths. Layers defined by composition. Core. Below mantle. Sphere with a radius of 3,486 kilometers. Composed of an iron-nickel alloy. Average density of nearly 11 grams/cm3. Layers defined by physical properties. Lithosphere. Crust and uppermost mantle, about 100 kilometers thick. Cool, rigid, solid. Asthenosphere. Beneath the lithosphere. Upper mantle. To a depth of about 660 kilometers. Soft, weak layer that is easily deformed. Layers defined by physical properties. Lower mantle. 660 to 2,900 kilometers. More rigid than the asthenosphere. Rocks are very hot and capable of gradual flow. Outer core. Liquid layer 2,270 kilometers thick. Convective flow of metallic iron within generates Earth's magnetic field. Inner core. Solid sphere with a radius of 1,216 kilometers.